I recently went to an industrial networking training event put on by Josh Vargas at Traceroute. And one thing that he really pushed me on was the need to segment networks based on what traffic actually needed to go through them. Now, this is something that I have always been resistant to. So I want to be able to go to communication to active and really scroll down and see all my devices out there and make sure everything is ready for the training week or to make sure everything is operating in the plant. But if I can see all those devices, that means that all those other devices are also seeing a lot of that traffic out there. And so I need to change my whole IP scheme. I'm going to split my training center into several networks, which brings us to the big challenge of doing this is how do we know, one, what IP addresses are actually being used and what we need to change, but also what is communicating with different devices. For example, here is a 1756 L81E, and this one here is pretty in-depth as far as communication because this is our trainer that we use to do a lot of communications exercises. So I can simply change its IP address. I need to change that. I know that. But then it's also communicating with everything that's down in this Ethernet. So I need to go find all these devices. But then even then, it's like, okay, is this all the devices? What about message instructions? What about other custom things? So initially, just like everyone who doesn't know about networking, I was like, isn't this something that Wireshark maybe can do? But no, this isn't something that Wireshark can help us figure out. So my next thought is to go up to my routines and really just start aimlessly scrolling through all the various programs that are in this. But there's over 7,000 rungs in this. So that's not a great strategy. We have a find. And so we control F with the find. We can find text. We can find edit zones, forces, items like that. We can't find like raw data. And so this is a good example where we want to export this Studio 5000 file and go look at it in a notepad type program. Now notice I said a notepad type program because in this case, Notepad++ is going to be our best friend. So we're going to do a save as, and we're just going to put this in, actually, we'll put this over here. And instead of saving it as an ACD file, we're going to save this as an XML file. And we'll go ahead and click save to that. And then open up a Notepad++. And this is similar to Notepad, but one that can do some really cool find and replace. But all we're going to use it for is the basic find. So what I do know about my old network is it is 192.168.1. And I want to leave the rest of it blank. And I'm going to do a find all in current document. What you're seeing at the bottom here is a summary of where it's actually used. So it is used on, line 30. That's going to be our path in our PLC. Then line 3950 it is used. And so let's just double click here because now we can see, okay, I get it. It's ports, but it's inside of bus, which is inside of our point IO. And there's its IP address, 192.168.122. And I can go up here and find its root. And its name is actually UM. And this is a module. So these items right here, which probably includes all of these, I can pretty easily find. I can just go down here. That's going to be all the items down here. So I'm going to have to hunt and I'm going to have to change those. But then the question becomes, were there any other items in here? And we do see some down here. So we have line 25,673. And I have no idea what this is. So we're just going to click on it. And okay, so this is a Modbus TCP client user defined instruction. I recognize the instruction name. And so I'm going to be trying to find 192.168.153, and I'm going to go try to find client _1. So let's go back over here and, this may be a time. Nope. I still think going to controller type is going to be a lot faster to find. Let's open that up. And over here, let's put in client. And there it is, client 01. And now we can cross-reference it. Or actually, I haven't used it much yet, but you have go to the first destructive. That does work pretty well. I'm about to get used to having that option. And so this is a Modbus TCP client user-defined instruction. And if we go into the message parameters and we monitor those and open up our arrow by it, then right there is the 192.168.153. Now I need to go figure out what this is. And we hope, and this is not going to work for all of them, but to figure out what that is, I'm going to go to communication to active, and then we'll just look for it. So 192.168.153, that's a micro 850 PLC. So I'm about to go, when I make this change, I'm going to have to find this one and change it as well. All right, then let's go back to Notepad+, because hopefully all of them will be something similar. So that was that one. And then, okay, so this one's the same thing. That's the 53 that's in the same group of data. Well, no, I just made a big old assumption. You know what that does. So let's double click on this one. Okay, and that's a client parameter. That was where we just ended up looking. And then we have one here. And this is also, it's in the same part of the user-defined functions. Okay, we're looking good. Okay, now we have a 52. Okay, now look, these are message parameters. So these are message instructions. I double click on that one. Then, yeah, we need to go find this message instruction. So it says that it is a message or MSG QBB read. So we're going to copy that and we'll go over here and we'll paste that in. And there it is. So we'll cross-reference it. Actually, let's try to go to the first destructive. And then if we look inside of it, our communications, okay, so it's going to need change there. So that's what a message would look like. And we have 3 of those. We're going to make a big assumption they're all the same. I'll go through those in detail because we have 3 more that I don't recognize. First of all, there's 53 again. Let's open it up. Okay. Now we have also, this is interesting. We have a Modbus server. And this is in the weeds of this user-defined data type. This one probably doesn't need fixed, but we should go look at it. I will look at it when I do this. And then we have 44. If we click on 44, okay, so this is stuff that this Modbus server is messaging. It's going to be really good information if we are actually doing some diagnostics. So probably that's the big thing. I could not figure out a different way to do this. We're going to export it. You can find your IO configuration once. Then we're going to find, well, in this case, we had a user-defined function block. I'd have never found this without using Notepad. And then we have 3 message instructions. Okay, I just got thinking, this still is only covering the items that our PLC is actively making communications requests to and from. It's not anybody touching HMI. So there's one more thing we should check. Now, let's see if I missed anything on this. Is we should go to the web browser and enter the IP address of the device. So let's enter 192.168.1.34. And virtual revolution opportunity. I actually had to Google this one, and I knew the time was coming, and I guess I just had not paid attention since version 33. The web server is disabled by default, which probably a good idea. It probably is a good idea. But yeah, so we cannot get to it. So we're going to need to go ahead and go online. So I'm going to communication to active and go ahead and go online with this PLC. And let's go to edit, controller properties, and security. And all right, the enable controller web page. I did read a little bit about this. What I just found is here, Studio 5000 application version 33 or later. The web page is disabled by default. Now, I thought it could come check this box, but apparently this must be done offline. So if we go to communications, go offline, we would be able to check the box, but that's not going to do us any good if we have a machine running. So that is going to be a no. We're not going to be able to do that. Since we're here, let's double check one other thing is if we go, yeah, we really do need that information. And I don't know of an easy way that we are going to get there. We could go to port configuration and grab some port diagnostics, but that doesn't give us the actual IPs. Now, okay, let's see if that's so on a CompactLogix PLC. So I'm going to open up our web browser and let's get a 192.168.122. Okay, so the CompactLogix PLC still does work. And before version 33, now I'm going to think about this, how we could really do this. This was really useful on previous PLCs is you can go to Advanced Diagnostics, TCP, and we can look at our TCP connections. And this would tell us every device that is actually talking to this. Now, I don't know how to get an equivalent in Studio 5000. So I'm up for any other ideas anyone has, but this will be a challenge. It'll be a challenge for me. It'll be a challenge for you. So throw down in the comments what you think, any tips you have. One thing I want to go ahead and throw out, because I kind of brushed up against it, Wireshark will not work in this instance. Wireshark, if you just throw it out on your computer and listen to traffic, it's actually mostly grabbing broadcast traffic. And this would not be broadcast traffic. This will be traffic with a specific target. And so that doesn't come in over Wireshark. Speaking of those networking classes, I did learn a lot. And here's a playlist with some really cool networking videos for industrial switches. Click here to follow me over there.